Docker in a DevOps World with Elton Stoneman.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. And the first announcement before we get onto the show, in January, I'm teaching another class of my .NET DevOps Bootcamp. You can sign up now to reserve your spot. But let's get into the topic for today. Elton Stoneman is with me today. He's an architect at Docker, and he's also an Azure MVP. Received the Microsoft MVP award in the Azure category from Microsoft, and you can find him at Twitter at Elton Stoneman, ELTONSTONEMAN. And he's in progress with his next book, and the book's called Learn Docker in a Month of Lunches. And so check the show notes for a discount code he's generously given us, and you can get a discount on that book, Learn Docker in a Month of Lunches. It's not out yet, but it's in progress and will be imminent. But Elton, welcome to the show. How are you, sir?
I'm good. Thank you very much. Thank you for having me. Yeah, thank you for plugging the book. That book's with Manning, and they have this kind of early access program. So I've written 12 chapters. You can read the ones that are in progress, and when the book's done, then you can buy the whole thing.
Hey, 12 chapters. That's a healthy book. If 12 and you're still in progress, that's going to be a good one.
Yeah. This whole month of lunches series they do. The idea being that there are 20 odd short chapters. You should be able to go through them in an hour or so. Lots of try it now exercises. Lots of labs to do. It's perfect for Docker because you can break it down into nice little small tasks. Start easy and gradually pile on more and more learning. So yeah, it's been fun to write.
Awesome. Now, you gave a talk on Docker at the .NET Conf, the virtual conference, just about a month ago, and just tons of great stuff there. I want to dive in, but just for the folks who didn't catch that or maybe aren't familiar with you, how did you end up in this space? What's your journey been?
Oh, it's been a fantastic journey. So I started my career as a .NET consultant. So I worked on some .NET projects for an increasingly large enterprise customers. So spent the last 10 years building big, ugly, monolithic apps, which I'm now spend my time teaching people how to break apart. So I was getting heavily interested in Docker when it was kind of pretty new. So before the 1.0 release, I was on a team where we were a proper DevOps team. I was managing the kind of services in the back end that ran up in Azure. And there's another part of the team who were building an Android device. And so we were a mixed team because they were all Linux people. I had a Windows background, but I've always liked Linux and never really spent enough time digging into it. And they were using this new thing called Docker to run their tooling. So they ran their own instance of Git. They ran their CI pipelines, all with Docker. And once I started looking at it and realized that it helps you get past that thing. If you're not from a Linux background, in the old days, you read about this fantastic open source tool. You went to look on GitHub and you had to download the source code and you had to build it and then nothing worked. And then you went to look at the forums and it was just people sniping at each other. All that goes away because you just do Docker run and somebody else has packaged it up, and probably the team who managed that project have packaged it up. So they've got it working properly. So I started using it with Linux. That accelerated my use of Linux quite a great deal. And my background is always in .NET. So when .NET Core came along, I was really interested in how, if the migration to .NET Core was ever going to be real, whether you would be able to, there'd be enough of the API that you could take your apps and bring them over. And then Windows containers came along. So all the great same packaging idea, the same portability and lightweight containers came into Windows. I was blogging about it and talking about it, and Docker had an opening at the time for an advocate. So I originally joined them part of their marketing team. And my role was going to the Windows community and teaching them about this stuff and showing them where it fit into the new ways of designing and building applications. Did that for a couple of years, then moved to as an architect at Docker on our partnership team, working with some of our bigger partners to see what happens, what they've got coming down the line, what we've got coming down the line, how we can kind of make things work together to make everyone's life easier.
Awesome. And Docker certainly has exploded in popularity and usage. And there's lots of documentation and tutorial videos out there about how to start using it and whatnot. But I'd like to, since this is your world and you're one of the architects at Docker, I'd like to get into your brain and get into the design philosophy about the strategy behind it all. What's the big problem that's being solved? And there's a lot of listeners out there who kind of hear, oh, container, but they're not really using it, and they're hearing, okay, it's a thing, but how should I be thinking about this thing, and how is our industry starting to change, and what problems are we solving? So can you dive into some of the strategy discussions that you guys have at the company about why the heck we're doing all this?
Yeah, absolutely. So it's kind of boiled down to three kind of main areas that we've been looking at over the last few years, because we have a lot of presence with developers who love the tools. We also have an enterprise product that we sell into bigger companies, and so we have small teams who are all DevOpsy and microservicey who want to use the product, and then we have bigger companies who have a huge legacy of software that they want to run everything on the same platform. So what's kind of emerged is there are three patterns that people are doing. People are taking their legacy applications, so maybe that's a .NET 2.0 web forms app that's currently running on a Windows Server 2003 machine. If you want to move that thing to the cloud, you've got a whole lot of questions you have to ask. If you want to get to a full PaaS solution, then you're probably going to have to rewrite that thing. Which is great if you've got a project team, but if some of these apps they haven't even got the source code anymore. All there is the runtime. So if you can take that thing and package it in a container, which you can do without any changes to code, you can take that whole legacy, put it in a container, and then suddenly you can run it on Kubernetes in Azure. And then that's part one of maybe your migration strategy. Is there a whole lot of things that we use currently, we're not actively developing. We just want to move them around and run them on the latest operating system, rather than be stuck on some older version. And then the second category is, well, that's our starting point. We've got this big monolith, but we are still adding features. We're still developing it. We're still working on it. If we move it into a container, then you've got some really nice patterns to break it apart. So currently it's a big monolith. If it's a big enough project, if it's like a 2 million lines of code, you're not converting that to a microservices architecture without 18 months worth of work.
Right.
And at the end of that 18 months, you've got the same feature set. You haven't delivered any kind of real business value. So what we talk about when we're looking at this kind of this journey to decompose your monolith is to break out individual features into new containers, plug them all together with the networking that Docker and Kubernetes gives you, which makes it all super, super simple. And then suddenly you're moving to a distributed architecture. You can take advantage of the benefits of microservices, being able to deploy different parts of your application with different cadences. Things that change regularly, you just update those. You don't need to test the whole 2 million line monolith. You just update the thing you just test the thing you're updating, which is nice and small. You scale them independently and all that sort of stuff. You can get the benefits without doing a full rewrite. So that's the second thing. And the third is I've got a brand new project. I've got a whole new team. We want to be able to get out fast and scale and all that sort of stuff. And then I'm kind of microservice-y from the start. So the great thing about that is either you're a new company, in which case you're in box number 3. You're just doing microservices. If you're in the same background as me, you're going to do everything in .NET Core. Doesn't matter whether your devs work on Windows and you want to deploy to Linux because .NET Core supports you. If you're a big enough company, you've got all three. And the great thing is it's the same set of tooling. So every project has this script called a Docker file, which packages up your application with everything it needs. When you're running developers were running, and when you're running in your test environments, you'll use this other thing called Docker Compose, which lets you plug containers together really easily. So you write one command and you bring up your whole application on your workstation or your test server, and then you'll have a Kubernetes manifest that describes the app for production. So it doesn't matter whether it's a 15-year-old Windows app or a brand new .NET Core app. They all have the same artifacts, same tooling to build them and publish them. So you get that level of consistency, which just simplifies everything.
Okay. Now, there are tons of people with legacy applications and lots of people who are struggling in that same journey. So all of those, and I won't go back before .NET Framework for legacy applications, but for all the .NET applications out there, is .NET Framework. They're tied to Windows. And can you talk about the practical differences today with the Linux ecosystem of containers and the Windows ecosystem of containers, recognizing that most of the people on the show, yes, they have a legacy application that is right now tied to the Windows kernel?
Yeah, absolutely. So the big thing to understand is that when you run a container, it's this really lightweight. It's a really lightweight unit for compute for your application. So it takes your application binaries and it puts this kind of really thin boundary around them. So inside that boundary, inside that container, I've got my own IP address and my own disk and my own. If I'm Windows, I've got my own registry. I can access the CPU and the memory from the server. But they're super lightweight, so they run the processes run directly on the host. And because of that, if I build an app to run in Linux, it has to run in a Linux container on a Linux server. If it needs Windows, then it has to be packaged to run as a Windows container, so it has to run on Windows server. So you can't run on my Windows server machine. I can't run a bunch of Windows containers and a bunch of Linux containers, which sounds like a big problem, but kind of really it isn't, because what you'll do in production environment, you'll have a mixed cluster anyway. You'll have a whole suite of servers. Some will be Linux, some will be Windows. You install Docker on all of them. The Docker API is the same, whether you're working with Windows or Linux. The Docker file syntax is the same. There's one or two small features that are slightly different in Windows and Linux, but they're fairly insignificant actually at this point. There's more or less parity. So then you have this cluster with a mixture of Linux and Windows, and you treat it as a single thing. So either you join it all together into a swarm if you want to use the Docker tools, or you join it together using Kubernetes, which is another way to manage these sorts of clusters. And then you're talking to, so then you throw it this file that describes your application. And inside there, you might say, my application, there are 10 pieces to my application. One of them is a core web component, which runs on Windows. And the other 9 are nice small components that are .NET Core, that they're new features that we've worked on, they run in Linux. And all you do is you say to the cluster, this is a Windows thing, and these are Linux things, and it works out which machines to run them on. The fact that I've got a Windows container running on a server over here and my Linux containers are on Linux servers somewhere else doesn't matter. They can all still talk to each other. If it's a distributed app where there's communication happening, containers just use their DNS name to find each other. The platform takes care of connecting everything. It's all kind of pretty seamless. So if you've got that situation with either some Windows apps and some Linux apps, or apps which are Windows and Linux, it supports you with all that thing. So I can go to Azure right now and spin up a Kubernetes cluster and say that I want 10 Linux workers and 10 Windows workers, and I can run everything on that pretty much.
Okay. And so recognizing that most of the people listening to this, if they haven't jumped to .NET Core, they kind of been waiting on the Windows containers. And what I think I'm hearing you say is, hey, there's no difference now. There's prime time. People are using it. They should go.
Yeah, absolutely. So the thing that's new this year is Windows supporting Kubernetes. So Kubernetes is what they call an orchestrator, which is a fancy term that just means it manages your containers for you. So in the world of a production cluster or a production-like test cluster, you don't log on and run individual containers. You have this descriptive file which describes all the parts, decides what to do. Up until this year, only Docker Swarm supported Windows machines in that cluster, which is Docker's orchestration technology. But now that Kubernetes supports Windows 2, all the major clouds suddenly have orchestrators that can run Windows containers. So if you're looking at this and thinking, well, we can't run our Windows apps, that's not the case. So the previous book that I wrote, which you can still buy, is called Docker on Windows, and it takes you through that entire journey. So every single example in that book is a Windows application. They're almost all .NET Framework apps. I take you on that modernization journey as well and show you how you can break up these things and add new .NET Core things. But there's no Linux anywhere in that book, and you can do that in production now.
Okay. So with a DevOps environment where people are starting at the source control structure and setting up private build, integration build, layers of testing and deployments, there's been some people who have hypothesized that, hey, you know what? Maybe the Docker container is the packaging format for a release candidate. What's your stance on that, about what file format you think the future is going to go to, and what do you see people using now when they package up the different applications for deployment? Do they deploy to the container on deployment time, or is the container itself the version to release candidate format?
Yeah, so the image, so ideally the image is your release candidate. So for folks who aren't familiar, the way you package up your application to run in a container, you write this script that says all the bits you need. Which if it's a Windows container, you're just really writing PowerShell in there to set up everything that you need and copying in your application binaries. And then you build that into what Docker calls an image, which basically is just a big zip file that contains your application and its config and its dependencies and even the version of the operating system that you want. And that's the portable thing. So I can share that either publicly with the whole world or with my organization. When you get to doing this with a pipeline as part of your DevOps approach, you're going to have on every single push to the source code, your source code contains, in your source code folder, there's also the Docker file, which has the description to package your app. And you can even compile your app using containers. So there's this really great thing that came with Docker a couple of years ago called multi-stage builds. So rather than have some other process compile my app and then inside my Docker file, I copy in whatever it compiled, I can have the Docker file itself, like part 1 compiles the app and part 2 packages the output, which suddenly means I don't really need a build server anymore. So anyone who's had a history like me, where once upon a time I was the build manager on a project, I had to look after. You have a literal server with Visual Studio installed on it, and it has to be the same version as all the developers, otherwise everything breaks. And so all that goes away because there is no build server. The container that compiles your app comes from somebody else's image, and Microsoft published these images that have MS Build and NuGet and the version of .NET that you need. So in order to build that app and run it, you don't need anything on your machine. You just need Docker. So that makes it really easy for things like GitHub Actions, because I can have some node spin up my application and build it from source code. If I'm a new joiner on the project, I don't have to spend 2 days setting up my machine. I just do Docker build and Docker run. So capturing all that stuff in the Docker file is really nice. And then so the CI process builds your application image and then stores it in a registry with some sort of versioning, whether that's your a release candidate naming scheme that you've got, or whether it's just part of your Git commit so you can track it back to the source code. And if you structure your Docker file correctly, these images are they're logically they're one single thing, but physically they're stored as lots of small things, and they can get shared and reused. So if the only thing that's different between version 1 of my app and version 2 is a 5 megabyte DLL, then the only difference in those images is 5 megabytes. So you want to get to the point where your CI process is really fast because the builds use the cache because they haven't changed since the last build. And then the thing that you're storing is just a small diff from the last thing that you stored. So you should be able to go and say anything that any source code revision, here's the Docker image that came out of it, and we can build that and run it. Sorry, we've already got it built. It's in our registry. We can run it and see what that version gives us. So yeah, the image as the deployment format is absolutely the way to go.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Let's get through some announcements. The .NET DevOps Bootcamp training course, another date was announced for the course. We had a fantastic class in October, and next class will be January 16th and 17th in Austin, Texas. And this class is based on my latest book published through A Press, which you've heard about, .NET DevOps for Azure. And if you'd like to learn more about how to set up that high throughput DevOps environment for your team, get the copy of the book, .NET DevOps for Azure, anywhere tech books are sold. Also, as many of you know, I'm available for hire. I love helping teams get better. And one of our very popular services is a 30-point DevOps inspection covering everything from your version control structure through builds, testing, quality control steps, to deployments, and even production monitoring. And between now and Christmas, we are giving away a few of these for free. Now, the price for this is $5,000, and we provide a comprehensive report with concrete recommendations and a plan for resolving any gaps we see. So send me an email at jeffrey@clear-measure.com. That's Jeffrey. And once the promotion schedule is full, that's it. We're full. But if you're a regular subscriber, then you have a good chance of getting one of these promotional inspections. So send me an email, and until that promotion schedule is full, we'll give you a free 30-point DevOps inspection that we normally charge $5,000 for as a special promotion between now and Christmas. So I'll be looking out for those emails. And now back to the show. I want to make sure I understand this correctly. So, example, my application, let's just say it's a Windows service or something like that, and it's 10 megabytes. How big is that Docker image going to be that is my release candidate, that is just that server where my binaries, essentially my application takes 10 megabytes? Roughly, what are we talking about?
Well, so it's the only answer that you'll ever get, which is it depends, but I can be clear about that. So if you've got one image on your server, so I've just installed Docker, I've downloaded the image to run my Windows service application, then that image size will probably be about 4 gig. Because it's got all of Windows Server Core, which is effectively all of Windows Server 2019. It's got the .NET Framework, all of your dependencies, and your application. But of that 4 gigabytes, 3.5 of that is Windows, and 490 is .NET, and then
Framework.
10,
yep.
Yeah, and then 10 is your own application. So the next image that you download for some web application, which also uses .NET, that's going to come in as 4 gigabytes, but you're not using up 8 gigabytes of space on your disk because it shares everything from the previous image. So if I've got 10 images on my machine, they all based on Windows Server, they'll all share that 3.5 gigabyte layer that's got Windows Server in it. They'll all share that 500 meg layer that's got .NET on it, .NET Framework, and then they'll just have their own differences. So, I'll have the 10 megabyte for my Windows service, I'll have maybe 100 megabyte for my web app. So if you look at them, it looks like they're all 4 gigabytes each. But if you look at the disk, they're all sharing the main parts of it.
Okay. So as time goes on, if I'm using the container image as my release candidate format, then I'm saving build artifacts that are deployable, essentially. Mm-hmm. And I've got 1,000 versions because I've done 1,000 builds over time. And I've got each one. So each one of those container images is only a diff on top of whatever the base image chain was. But yes, those images that I'm saving that are the product of my build that are ready for deployed, how big should I expect those to be generally if the application inside is 10 megabytes?
How big should you expect the images to be?
Right. It's not 500 megabytes because that's right.
Yeah, if they're all on the same server, then each individual one will the only amount of disk will be the diff from the previous build. So on your build server, if it's the same server is building all these images, then it'll reuse everything each time except for the last little tiny bit. So when I share that image to a registry, it might upload the whole lot. So there's the logical image size, right, which is if I only have one image on my machine, how big will it be on disk, which is everything, Windows, .NET, and my app. Sure. And then there's the physical size, which depends on if you've already got those layers from another image.
And incrementally, if the computing environment is stable, then we're not really changing those. And it's just, hey, I changed some code, I did a rebuild, now I have a new deployable version. So roughly there's less than a megabyte overhead on top of my application size?
Overhead, there's almost no overhead. So okay, the size will be the size of your application. Okay. If your Docker file is structured so that it's structured so that the instructions are the most frequently changing thing is at the bottom, then it won't break the cache. It'll reuse everything from above. So if I just change the code, then all I'll get in the diff from the previous build is the 10 megabytes of my DLL or whatever it might be. But if I also change the dependencies and add some other reference to some other DLL, then I'll add the dependencies in as well. So it depends on what you're changing for each layer.
Well, good. That's been a point of confusion in the Windows world. And actually, I was at the Microsoft Ignite conference, and there was a question on the Microsoft live stream about the size of Windows images and 4 gigabytes and then 500 megabytes. And then someone said, oh, but yes, containers are how you should package up, release candidate, the package format. And a lot of people are confused, like, that's a lot of disk space. But actually,
Yes.
the incremental, that's the chain. Once you have the environment that you're going to run on and you're done, then you're going to have lots of release candidates, one for every build. But those things are only the size of your application.
Exactly.
And just clear that up, because a lot of people worry, the Windows container images are larger than Linux, but so are Windows VMs.
Well, exactly, and the payback for having that huge image is that you can literally take your app from a Windows 2003 server and bring it into Docker, because the reason you've got 4 gigabytes worth of Windows Server is the backwards compatibility.
Yeah, that's true. Okay, how much uptick are you seeing on the Windows containers? I know the Linux containers have taken off like wildfire.
Yeah. It's kind of hard to judge, but most of the enterprise customers we deal with have mixed workloads. So, it's smaller shops who are new startups who are doing microservice things with .NET Core or Node.js. They stick with Linux, but anyone with an established footprint will have Windows stuff in there too, and they want to move it and run it in the same way. So I think I couldn't give you numbers, but the majority of our enterprise customers have Windows workloads too. And bringing that into Kubernetes is only going to accelerate that. So the Kubernetes community have been really receptive to the idea of Windows. That the majority of the people who are contributing the code to make that happen are Microsoft or Docker or from other fairly big companies. But there's a lot of interest in that happening. KubeCon, which is the big Kubernetes conference, is happening right now, and there are sessions there which are dedicated to Windows people. I think from both sides there's a lot of interest. From people who've got the Windows background, I can move into this new world without having to rewrite all my code. And then from the Kubernetes background, there's we can welcome in a lot more applications here and standardize on how we deliver things and that's the great thing. If I've got this cluster with all these mixed nodes, the thing that I operate on, the thing that I work on is the kind of container level. I don't really care what's underneath. So I talk to the cluster to get logs out or to connect to something, to run a command to see if something's going wrong. And that's all the same sets of tooling. Doesn't really matter what's inside the container. So it's a lovely layer of standardization on top.
Okay. And I've had a few past guests talk about containers, and they've kind of make the assertion, containers, that is the unit of standardization going forward. But Microsoft is also pushing platform as a service offerings with app service functions and web jobs and website and even Azure SQL. So from an architectural strategy perspective, how do you guys at Docker think about the things of, hey, yes, this should absolutely be in a container, and versus, in these scenarios, maybe it makes sense to use a PaaS service directly instead of a container. What are the discussions inside Docker about those things?
So I think some things are pretty clear cut. So you can do stateful applications in containers, but it's hard. It's hard to get that right, especially if you want something like a distributed database. So we do have customers who run things like Postgres in containers. But if you're in the cloud, we'd say, use Azure SQL, because your containers can connect to that thing. That's fine. They're probably running in the same data center. So you get all the backup and storage and scale out that you get from that managed service. On the other end of the spectrum, functions like Azure Functions is really good, and there's no need for you to write everything in a container, because there's a lot of optimization in Azure Functions that will keep things hot for you, and even the startup time of a container might be more than a function. So if you're looking at a fairly modern architecture with a bunch of containers doing your core work, because you always need a certain amount of scale running. So let's leave that in our containers on our Kubernetes cluster. That's going to talk to Azure SQL and maybe the service bus in Azure if I'm posting messages, and I've got Azure Functions as a separate entry point to my application. Where it gets fuzzier is if I've already got an application that I'm looking to migrate, and then it kind of comes down to non-technical things like, is it important to you to be able to run the same thing everywhere? So do you get to are you happy with the situation that developers, if it's a PaaS service, there's almost no similar local experience. There are there are emulators for certain things, and you can kind of approximate the end result. But with a container, what's running on your laptop is the same thing that will run in production, the same set of binaries all the way down. So if that's important to you, if the idea of being able to be portable across clouds is important to you, then you can package your stuff to run in Docker. You can write your Kubernetes manifest to describe the deployment, and you literally spin up an AKS cluster and run it in Azure. And you spin up an EKS cluster and run it in Amazon. It's the same thing. You're deploying the same application file to describe what you want. If that's important to you, then those things kind of live in the container world. But if you're if you're fixed on a particular cloud anyway, then it's not quite so clear cut. So it depends very much on what it is you want to leverage. I mean, the application PaaS offerings, they have the benefit that you can get started very, very quickly. You don't have to. They make it super easy for you to take your code and just run it, and then scale it up to as much as you need. But they don't necessarily give you the option to kind of tweak and tune all that stuff to do everything that you might want. So, maybe not every application platform is supported. Maybe you can't run all the dependencies that you want to run, that sort of stuff. So it's the usual trade-off between this stuff super easy to get started with, but it doesn't give me all the knobs I need to tune things. And then Kubernetes is the complete other end of the spectrum, like massively complicated, but you can kind of take that stuff anywhere and do kind of anything with it.
Mm-hmm. No, that makes a lot of sense. I'm wondering if, I look back to the transition from physical servers in a rack to virtual machines, and how that was a big change. And there was a lot of people who are getting really good at setting up the hypervisors on VMware and then Hyper-V and whatnot. And now I think, why would I do that? Let me just, if I'm at a hosting company, let me ask a hosting company for a VM, or let me ask AWS or Azure, hey, give me a VM, and it's up and running. I'm wondering if containers will kind of become the normal and maybe built into some of these services where we don't even know that they're there, but they're just baked into the infrastructure.
Yeah, absolutely. So, I mean, that's the kind of, you mentioned about containers becoming the de facto way of running stuff. Well, so GitHub Actions, which is the new kind of pipeline that GitHub are baking in, you just write a file that describes the steps to take, and each of those steps runs in a container. So, it's containers kind of all the way around. And once you've made that move to say, this is how we'll do stuff, then everything kind of works in the same way. And you're absolutely right. So I've talked about AKS, which is Azure's Kubernetes service, but on Azure, they also have the container instances. So I can run, a single container. And I can do the same thing. I can write my application, write my Docker file to describe it, build it in an image, and share that on Docker Hub, or I can share it on Azure Container Registry. And then I can run that thing in a single instance on Azure Container Instances and just pay for the compute power while it's running. Or I can run it on a 200 node Kubernetes cluster. And in each case, I'm going to run an AZ command to deploy it. And I'll with the Kubernetes example, I'll have a YAML file to describe the application, but it's the same code running. So it just gives you an awful lot of options to run this stuff anywhere.
Right. And I was excited also at the Ignite conference, the people talking about IoT, and then the latest Raspberry Pi even supporting Linux-based containers. And I'm thinking, okay, you get an application running, it's got all those different pieces, and then just the number of options you have in order to run a particular application in a container, and just be able to choose the device, and how small those devices are now. Just a system on a chipboard running off of a car battery somewhere could be running your application in the container.
Yeah, it's super impressive. And so we worked, Docker, the company, we worked with ARM, who make the processors, to make that experience as simple as possible. And one of the selling points for my new book that I'm working on is every single example is packaged to run on Linux, Windows, and on Linux it can run on Intel or ARM. So you can follow along with the book whether you're running a Raspberry Pi or a $6,000 Mac laptop. And in order to make that happen, I have to take a little bit of extra work on myself. But it's for each example, the source code doesn't change, the Docker file doesn't change. Effectively, I build it 4 times, once for Windows, once for Linux on ARM, and then I push it to the registry. And then when you download that image to run the container yourself, Docker on your machine knows that I'm running 32-bit ARM on a Raspberry Pi, and it pulls down matching image version, and it knows I'm running Windows Server, so it pulls down the Windows Server version. And so, I'm using that to make that book easier. But actually, you open up a whole bunch of things. And Amazon have they have ARM VMs that you can spin up now. So exactly the same experience with EC2. I can spin up a VM. I can say I want ARM instead of Intel, and they're almost half the price to run. So, if you've got a cross-platform application...
if you don't care. Absolutely.
Yeah, absolutely. If it's .NET Core, if it's Java, or if it's Go, and you can take your same Docker file, build it with ARM, deploy it, run it, see how it works, gives you an awful lot of options.
Now, those examples in the book, that sounds fantastic. What languages are your examples being delivered in?
Yeah, it's hard because my background is all .NET, but I can do
other
we
pieces.
Love
.NET here.
Yeah. So, but I can only do .NET Core because I can't do .NET Framework because I couldn't build it for Linux.
Okay, but that book is for C# developers.
No. Learn Docker in a Month of Lunches is for any person. The previous book, Docker on Windows, that's for C#.
That was C#. And so are you using a variety of computer languages in your new book?
In the new one, yes. Yeah, I use .NET Core, I use Node, I use Go. I even have to do a Java example because I don't want to exclude people.
Sure.
So I had to dust off my Java knowledge from a few years ago. And that's really interesting, actually, because you look at these programming languages have such different ideas about doing stuff, but the Docker file is very similar because the Docker file is the same process in each case. There's a step to compile the application, whatever that means for that stack, and then a step to package it up. And then once you've done that and you've got your image, you just do Docker container run. You don't care what went into it. So yeah, it really does kind of make clear to you that everything becomes the same kind of thing.
Fantastic. Well, Elton, before we wrap up here, we've talked about so many things. Are there any go-to resources or where you would point the listeners to if they want to kind of dive in right now?
Oh yeah, sure. Yeah. So I mean, if you're a Pluralsight subscriber, then there's a whole bunch of courses from me and from some of the other people. The Docker equivalent of MVPs are called Docker Captains, and there's a few like Nigel Poulton who do Pluralsight stuff that's really worth digging into. If you're from a similar background to me, then I do a workshop at various conferences, but all the content for that is online. It's all public. That's on a website called Docker and Kubernetes for .NET developers. The website is https DAK4.net. So DAK for .NET. If you browse to that, and I'm sure we can give you if we give you a link to it. There's a whole kind of there's about 300 slides there. There's a GitHub repo with all the examples. It starts literally from zero, taking you through the basics of Windows containers and running .NET apps. And then we kind of like about 150 slides in, we switch to Kubernetes and we talk about .NET Core. So it's a kind of self-paced thing. You don't need anything to follow along except Windows 10 with Docker installed. So that's a kind of great place to have a look and get started.
Awesome. Well, this is a great conversation. Good information. I appreciate you coming on the show, Elton.
No problem. Thanks for having me. It's been great fun.
Absolutely. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.